Okay, good afternoon everyone. AI coding assistants, they're everywhere right now. Every vendor, every LinkedIn post, every conference. It's all about generating code faster. Now look, I totally get that. The demos are impressive. You typed a prompt, AI writes a function, feels like it's magic, yeah? Well, I'm trying to challenge something today. I don't think that faster code generation is actually a problem that most teams actually need to solve. So think about your last development, or maybe the one that you're working on right now. How much of your time was actually spent coding? 10%, maybe 15%? The rest, yeah, is meetings, context switching, trying to understand someone else's design, decisions, waiting for reviews, stakeholders, figuring out why that pipeline broke. Does anybody recognize that pattern? Yeah. Typing speed, I don't think has ever been a bottleneck in any of the projects I've worked on. So this talk isn't about an AI tool, it's actually about what happens after you deploy the tool. And while the real opportunity with AI is organizational and not individual productivity. So I'm going to take you through CDL's journey. We rolled out Amazon Q Developer to over 150 engineers. We did see real results, but we quickly realized that the bigger opportunity wasn't in the tools, it was in rethinking how we work in its entirety. I'm Matt Houghton, I'm an architect at CDL, and we build software for the insurance industry. If you've ever bought a policy here in the UK, our software was almost certainly involved somewhere in that process. We're an enterprise scale insurtech. We've got hundreds of engineers, complex domains, and decades of expert knowledge that's baked right into our systems. In early 2024, our architecture team started to look seriously at how AI could be integrated into our software development lifecycle. And I want to stress, this wasn't a side project. This wasn't somebody installing a tool on their laptop and seeing what happened. This was a deliberate, structured evaluation. We want to answer a specific question. Can AI coding assistants make a measurable difference to how engineers work? And if so, which tool, and how do we roll it out responsibly at scale? Now that question led us down a path that we didn't fully expect, and it started with a bake-off. In August 2024, we ran what we called an AI Day. This was a formal controlled experiment, a bake-off between Amazon Q Developer Pro and an alternative vendor's tool. So this is how we set it up. We took 40 developers across 8 different career levels and split them into 3 groups. A control group with no AI tooling, a group using the alternative AI tool, and then finally a group using Amazon Q Developer. And each group tackled the same time-boxed coding challenge. Let's take a look at what happened. The control group, the one with no AI assistance, completed the task in 3 hours, 15 minutes, with a quality score of 3.25 out of 5. And their average career level was 5, so 8 being the highest. These were clearly our more experienced developers here. The alternative AI tool group finished in 3 hours, 7 minutes, so slightly faster, but their quality score actually dropped to 2.75, so faster, but worse. Now, look at the Q Developer group. Completion time of 1 hour, 50 minutes, a quality score of 3.5 out of 5, the highest of all 3 groups. And here's the kicker, their average engineer level was 3.75. These were less experienced engineers. Let that sink in for a moment. Engineers with a lower average career level completed the task 43.6% faster while achieving higher quality scores than the control group with more senior developers. But this wasn't just a speed story, this was actually an enablement story. AI was clearly leveling the playing field here. It was giving less experienced engineers access to patterns and approaches that would normally take them a few more years to accumulate. That's what convinced us. So we chose Amazon Q Developer Pro as our primary tool, partly for those results, but also for some practical reasons. In particular, the elastic subscription model meant that we could scale without committing up to a year in advance for per-seat licensing. And also, QDeveloper had some code transformation capabilities that were unique to it at the time. But choosing the tool was just the beginning. After the bake-off, we extended the trial to 100 engineers over a following few months. And this is where we learned something that I think a lot of organizations miss. Deploying the tool is not the same as adopting the tool. We had QDeveloper available, people could use it, we'd paid the subscription, but usage was patchy at best. We had maybe 30 active daily users. Some teams were enthusiastic, others hadn't really engaged. The tool was there, but the habits hadn't changed. So in March 2025, we ran a second AI enablement day. Not a repeat of the bake-off, this was a day purely focused on helping people get better at using the tool. Hands-on workshops, real-world scenarios from our actual code base, tips and patterns that actually worked in our context. The results were immediate. Active daily users tripled from about 30 to over 100. Suggestion acceptance doubled. And within a few weeks, 2/3 of roughly our 150 developers were using QDeveloper daily. So the key lesson here, ongoing enablement is what drives adoption. It's not just deploying a tool. You can't hand somebody a new instrument and expect them to play it. You need to teach them, give them practice time, show them what good looks like. And this is where grassroots energy meets top-down investment. You need developers who are genuinely excited about the tools. These are your champions, your early adopters. But you also need leadership that's willing to invest time and resources in enablement. Actually carve out days for it, make it a priority. Neither works without the other. So here's what we realized. We'd made code generation faster. Fantastic. But our product owners were still developing requirements the same way they'd always done. Our architects were still reviewing designs. Our developers were still context switching between tools, copy and pasting between systems, spending half of their time on things that weren't actually writing software. We'd optimized one step and a process that was designed entirely for humans. So think about it. Our existing software development methods, Agile, Scrum, whatever flavor you use, they're all built for kind of iteration, duration measured in weeks and months, things like sprint planning, 2-week cycles, quarterly releases. These cadences exist because humans need that time to coordinate, communicate, and build shared understanding. Delivering software is not just about writing code. I expect you guys as developers here who've worked with legal teams, commercial teams, compliance teams, and marketing teams on actually delivering your software out to real paying users. But that AI enabling cycles measured in hours and days, if the code generation takes minutes instead of days, but the planning and other aspects still take weeks, then all you've done is moved your bottleneck. You haven't removed it. So there's a line I keep coming back to. Trying to bolt AI onto an existing process is a bit like adding more sails to your boat when what you actually need to do is build an engine. We need to think bigger. Not how do we make developers type faster, but how do we actually reimagine the entire development lifecycle with AI at the center? And that's where AI DLC comes in. AWS published a paper last year, the AI-driven development lifecycle. And it articulates something I think is critical. We need to reimagine, not retrofit. At reInvent 2025, Lilia Ayboyburova from Prime Video and James Hood from AWS did a talk, and they drew a really clear distinction about AI-assisted versus AI-native development. AI-assisted is what I guess most people have been doing up to now. You paste requirements into a chatbot, you copy and paste the generated code into your IDE, you paste context into a documentation tool, maybe you're updating Jira with some output from some AI. You're using AI, but in isolated ad hoc ways. It's bolted on. AI native is different. The AI tooling is embedded throughout every step. Every role is enabled with AI, not just developers. Agents own multi-step workflows end to end, and critically, context is shared throughout the tooling and infrastructure. It's not siloed. And that's the shift that leads to organisational productivity transformation, not faster typing. It's a fundamentally different way of working. The AI DLC pattern is a rapid loop. First, AI creates the plan. It orchestrates planning, task decomposition, architecture suggestions. Then humans verify that plan. Developers validate the approach and make judgment calls. Then AI executes the plan with human oversight. AI refines based on feedback, and humans verify the outcome. And this loop repeats rapidly. Again, we're talking hours, not weeks here. The analogy I find most useful is autopilot in aviation. The pilot sets the heading and the altitude. The autopilot handles those moment-to-moment adjustments, thousands of micro corrections that would be tedious and error-prone for a human. But the pilot still intervenes for things like turbulence and for landing and for anything unexpected. That's AI DLC. The developer sets the direction, AI handles the execution. The developer intervenes when judgment is needed. And there are two dimensions to this. First, AI-powered execution with human oversight. AI does that routine work, humans make the decisions. Second, dynamic team collaboration. As AI is handling that routine coordination type work, teams will now get more time to come together in more collaborative spaces for real-time problem solving and rapid decision making. Now, for any of this to work, AI needs to understand your context. It needs to know your standards, your patterns, and your constraints. And that brings us on to the concept of steering. So let me ask you something. Who here, maybe by a show of hands, have joined a new company or a new team, spent the first week, maybe first month or more, just trying to get up to speed? Yeah. Organisational constraints, coding standards, internal policies, architecture patterns, deployment processes. You need to absorb all of that before you become fully effective. And honestly, half of that I don't find ever written down. It's tribal knowledge most of the time. Now, imagine your AI assistant. Well, it does have the same problem. You give it a task, it generates code that's technically correct, but it doesn't follow your team's conventions. It uses maybe the wrong logging library. Maybe it structured the API differently from everything else in your code base. It doesn't know about that architectural decision that your team made 6 months ago. So this is where steering helps. Steering provides persistent knowledge about your project through markdown files that live alongside your code. Instead of explaining your conventions in every chat message, steering files help ensure the AI follows your established patterns, libraries, and standards automatically. The benefits are straightforward: more consistent code generation, less repetition, better team alignment, and project knowledge that scales alongside your code base. Tools like Kiro implement this with different inclusion modes. Some steering files are always included. These are kind of your core principles that apply to everything. Some are conditionally included. Maybe they activate on a specific file type. And some are manually included. The developer will pull them in when they're actually relevant. And this is smart because we've all heard about the context window limits of AI models. With steering, you're not dumping everything into every conversation. You're giving the AI the right knowledge at the right time. But here's the thing, steering's great for those static rules and conventions, kind of things you know up front. What about the knowledge that you don't actually know you need? What about those decades of institutional knowledge spread across architecture decisions, compliance requirements, etc., etc.? That unique domain expertise that makes your company and not anybody else's company. You can't fit all of that into steering files, so you need something a bit more. So this is where context store comes in. And this is part of the talk where I'm going to go a little bit deeper technically, because I think this is where I've seen real leverage. So approaches like Vercel's agents.md have shown that embedding a compressed documentation index directly into your context files get you some really excellent result. And their approach uses keyword-based lookup to point agents at the right markdown files, essentially. And we've had some real success with that. For a single framework, it works great, where you know that structure up front. But most organizations, they're not going to just be tied to a single framework. Organizations have decades of that institutional knowledge across multiple domains. Again, architecture decisions, compliance, integration patterns, team conventions. You can't compress all of that into a static index. So the idea is simple. Use steering for the rules that always apply, and use the context store when the agent needs to find relevant knowledge that it doesn't know exists up front. So I'll walk through the key differences between the two. Steering uses keyword-based lookup. The context store uses semantic retrieval. It finds knowledge by meaning, not by just matching keywords. Steering loads its index into every session, which does cost you tokens, whether you need it or not. The context store is more query-driven and on demand, and you're only paying for what you actually retrieve and then pass on in your context window. Steering works well for a single framework or domain. The context store is unified across all of your domains. And critically, the context store is searchable by meaning, so vector similarity, not just simple string matching. So this is how we've built this. And I was inspired by a talk from fellow community builder Lalit Kale at the AWS Dublin Community Day late last year. I took Lalit's suggestion and implemented an architecture that provides AI-assisted access to the organizational knowledge store via Model Context Protocol, MCP. The flow is relatively straightforward. My Kiro IDE connects to a remote MCP server hosted on Agent Core. We use IAM authentication to do that. When the AI needs context, it queries the MCP. That MCP tool performs semantic retrieval against the Bedrock knowledge base. The knowledge base itself is fed from source documents, so context flows from an S3 bucket through to Bedrock's embedding pipeline. All that information gets chunked and vectorized and becomes searchable. The source bucket is our single source of truth for organizational knowledge, and here the structure matters. So we've got things like policies, architecture standards, ADRs, open API specs. Maybe you've got product requirements, maybe in the Amazon PRFAQ format, and domain knowledge organized by bounded context. So the key insight here is that standardized formats really do help you. So our ADRs, for example, follow a consistent template: context, decision, and consequences. So the embeddings capture the reasoning behind the decisions, not just the outcomes. For example, PRFAQs, the AWS format, frame specs around customer value. And open API specs and async API specs can stay in their native YAML format. And you're balancing there between human readable and machine parsable. So when a developer is working on, say, an insurance claims integration at CDL, and the AI needs to understand the data model, it doesn't need to know what document exists that describes this. It simply queries the knowledge base by meaning. How does claims data flow between systems? And the relevant chunks, maybe from multiple documents, come back. Documents go in, vectors come out, the IDE queries by meaning. That's the core of it. So we're going to do a quick recording here of this working in Kiro. So I've got a project that contains some code that I created during a proof of concept. I decided now I want to take this forward and make it more production ready. So I'm typing away to Kiro here, and it's understood the intent. What I'm doing is taking that proof of concept code and I'm wanting to put a CI/CD production grade pipeline around it. It's loaded CDL standard steering, and the next step is for it to search that context store for relevant information. Given that I'm creating a pipeline, it's going to search for CI/CD pipeline, and what it finds is our standard blueprint for how we do that at CDL. If we look at the pipeline configuration that's actually been generated by the AI, you can see it's used some certain things. So it's actually using a pull-through cache here. Now, to have generated that, you would have to have read our documentation that says when you're doing this at CDL, you always use our pull-through cache. You don't directly query it from Docker Hub. Fortunately, all of that is in the context store, so AI has got the right information in order to build it the CDL way. So some tips around the directory structure for the context store. On chunking quality, the Bedrock embedding pipeline chunks documents before you vectorize them. So if you mix up unrelated content in the same directory or using consistent formats, chunks can start to bleed across topics. Clean separation by categories, so policies, ADRs, specs, domains, means that the document is self-contained and has got a much better chance of being chunked cleanly. The second tip is around metadata filtering. Bedrock knowledge bases can use things like S3 prefixes as metadata filters. So a well-structured bucket helps you scope retrieval into a specific domain or document type at query time, reducing noise and improving precision. If everything's just in a flat bucket, you're going to lose those levers. And finally, maintainability. Somebody's got to curate all this knowledge. So when a new team member adds a document, the directory structure kind of gives them a hints and tips on where it should go exactly and what format to use. Without that, the bucket starts to drift into more of a dumping ground, and therefore retrieval quality starts to degrade over time. So we've built this context store, the documents go in, the vectors come out, the IDE can query it by meaning. But here's a question you should be asking. How do you know this is actually returning good answers? Because if your knowledge base starts to drift, if somebody updates a document, say, and the chunking breaks, or the embeddings degrade, or a new domain gets added without proper formatting, you're not going to notice that immediately. The AI will still return something, it just might be wrong, or incomplete, or subtly misleading. And that's potentially worse than returning nothing at all. So we built in automated retrieval augmented generation, or RAG, evaluations. Here's how this works. So we've got an event bridge schedule, one per knowledge base, that fires on a cadence. Maybe that's daily, weekly, monthly, whatever makes sense for that domain. That triggers a Lambda function, which creates a Bedrock evaluation job. The evaluation job takes a JSON lines data set, their prompt and expected answer pair. These are real questions that developers would actually ask. We've got reference responses in there, and we've validated all that by hand. Bedrock runs those prompts against the knowledge base, generates those responses, and evaluates them across 7 different metrics. When the job completes, the results land in S3, and the second Lambda picks them up, compares every metric against a baseline threshold. If anything drops below that line, then we're going to get an S&S alert that goes out to the team. So the 7 metrics, they're all built into Bedrock's RAG evaluation for knowledge bases. They are correctness, so is the answer actually factually correct? Is the answer complete? Did it cover everything it should? Is it helpful, actually useful to the person asking the question? Does it have logical coherence? Does the reasoning hold together? Faithfulness, is the answer actually grounded in the source document, or is it hallucinating? And then citation precision and citation coverage. Is it pointing to the right sources, and is it citing enough of them? So each metric has a baseline threshold, as I said, and we've calibrated that as we've run these evaluations over time. Again, any metric that drops below that baseline, we're going to get an alert with the specific violation details. So that means if somebody pushes, say, a badly formatted ADR or a new domain, a document that doesn't chunk well, then we're going to catch that in non-prod before developers start getting bad answers. So the key insight here is that a knowledge base isn't a set it and forget it type of thing. It's a living system. Documents change, new domains get added, formats evolve. Without automated evaluation, you're trusting that the retrieval quality is just going to stay high. Trust does not scale. The data sets themselves are all version controlled alongside the infrastructure. At CDL, we use GitLab for our CI/CD, and that's validating the JSON lines files for the correct format, running the test, and syncing the data sets into S3 buckets on merge. So the whole thing is repeatable, auditable, and catches regression points before they reach the developers. Think of it kind of like an integration test for your organizational knowledge. You wouldn't ship code without tests, so why would you ship knowledge that an AI can use without them either? So tooling and context get you so far. Steering files, context stores, well-structured knowledge bases, they all give AI the information it needs. But someone still has to curate that knowledge, validate the outputs, and make judgment calls that AI can't. The tools amplify your capability, they don't replace it. So that raises the question of what kind of developer thrives in this new world. Well, Werner Vogels, even today here at the summit, was talking about a concept during his final reInvent keynote and at the keynote today, and I think it's one of the most important ideas in this space right now. He described this problem as verification debt. So here's the idea. When you write code yourself, comprehension comes alongside with that creation. You understand the code because you built it. You made the decisions, you consider the trade-offs, you know why it works the way it does. When AI writes the code, you have to rebuild that comprehension during review. The code arrives instantly, but understanding does not. So going back to the James Hood AWS talk at reInvent, he made this really concrete in the Prime Video reInvent talk example. So he built a new feature and it took him 2 days. And he did this in a code base and a language that he didn't know. And the actual code generation, that maybe took James 2 hours. So why did he spend 2 days on this? Well, he followed along. He questioned aspects of the code. He applied his human judgment. He didn't just accept the output, he owned it. And that's what made it production ready. The difference between vibe coding and AI native development is ownership. Werner outlined qualities that separate developers who thrive in this world. I want to highlight some I think are most relevant to what I've been talking about today. First one is communicate with precision. Natural language is ambiguous. If you give AI a vague prompt, you start to get vague code. Developers who get the best results are the ones who write detailed specs before they even start prompting. Precision in, precision out. Second point is own quality. Werner said it simply again. The work is yours, not the AI tools. You can't blame AI for a bug in production. You reviewed it, you shipped it, it's your code. Thinking systems. Don't just think about the code that's been generated in front of you. Think about feedback loops, second order effects, how this change that you're doing is going to ripple through the system. Become T-shaped. Develop deep expertise in your domain, but cultivate enough range across different disciplines. Think about the context store, the architecture, the domain knowledge. Someone has to curate all of that. That takes breadth. The developers who are going to thrive in this new world aren't the fastest coders, they're the ones who curate context and own quality. Okay, so let's talk about how you actually know if any of this is working. I've seen loads of companies and organisations measure AI success in what I would consider the wrong way. Lines of code generated, tickets completed, AI suggestions accepted. These are all activity or output metrics. They tell you that the tool is being used. They don't tell you if it's making any difference or making anything actually better. So what do you measure instead? Well, we've heard about these for years. Things like DORA metrics, deployment frequency, lead time for changes, change failure rates, mean time to recovery. These tell you if you're actually delivering better software faster. Time to production, from requirement to live deployment. Not time to put some code into a Git repo. Time to production. Actual customers actually paying to use the software. Architectural consistency. Are teams actually following your architecture decision records and established patterns? If AI is generating code that drifts from this architecture, that's a problem, not a success. And finally, friction reduction and toil elimination. How often do engineers need to get in and do manual interventions? How much repetitive work has actually been automated away? One metric is from Amazon. They published something called the cost to serve software model, or CTSSW. It gives you an economic outcome metric, total cost of delivering software divided by units of software delivered. In 2024, they saw improvements of a 15.9% reduction in cost to serve year over year, and an 18.3% increase in weekly deployment weekly production deployments per builder, and a 30.4% reduction in human interventions per deployment. To put that into business terms, for a company with, say, 1,000 developers with an average cost of $130,000, a 15% CTSSW improvement represents $20 million in cost avoidance. That's how you make your business case. Not our developers accepted more AI code suggestions, but we deliver more software, faster, with fewer failures at a lower cost. One more thing before I start to close, and I'm going to keep this brief because I think that you guys will know this intuitively. AI is a multiplier, certainly. If your security posture is strong, AI accelerates safe delivery. If your security is weak, AI accelerates the creation of vulnerabilities. Without proper controls, AI will simply auto-complete your existing chaos at a faster rate. So before you implement AI DLC at scale, make sure your foundations are solid. On the CI/CD side, think about secret scanning, vulnerability scanning, infrastructure as code security, open source license compliance, software bills of materials. We've seen some great examples in the last few weeks of open source things being compromised. How many of those made it into production pipelines, I wonder? On the runtime side, think about guardrails with something like AWS config. This catches overly permissive security groups, public S3 buckets, unencrypted data stores, and non-compliant configurations. And together, these things create defense in depth that enables safe, rapid iteration. You can move fast because you have the guardrails to catch mistakes, whether those mistakes come from us as humans or from AI. So let's bring this together. We started with a bake-off. We saw that AI tooling could level the playing field. Less experienced engineers producing higher quality work faster. We scaled that to about 150 engineers and learned that enablement, not deployment of tools, drives adoption. But then we realized we're optimizing one step in a process that was largely designed for humans, and that led us on to AI DLC, reimagining the development lifecycle with AI at the center, not bolted onto the side. We explored how steering embeds team knowledge into the tools, how a context store with semantic retrieval gives AI decades of institutional knowledge that it doesn't know exists, and how MCP connects your IDE up to that organizational knowledge. And we talked about the human side, verification debt, the hidden cost of AI-generated code, the Renaissance developer qualities that separate the developers who thrive from the ones who just generate more code. AI DLC is not a productivity hack, it's an organizational transformation, and it requires solid foundations, outcome, not output, ways of measuring success, and fundamental changes to work patterns, significant investment in context curation, and developers who own quality. You can't succeed with purely bottom-up grassroots energy, and you can't succeed with purely top-down mandates. You need both. So 5 questions to take back to your teams if you're thinking about AI DLC. 1, do we have the organizational foundations in place? Infrastructure guardrails, CI/CD security, runtime controls. 2, are we cultivating Renaissance developers who can curate context, validate AI outputs, and make judgment calls? 3, are we investing in organizational context, steering, knowledge stores, standardized specs, so that AI has what it needs to be actually useful? 4, do we have that both grassroots energy and leadership support driving this change? And 5, are we actually committed to continuous enablement of this, not just a one-off rollout? If the answer to any of these is no, then these are your first priority, not switching on an AI tool itself. Thank you very much, and please remember to fill out the session feedback form.